Okay, everybody, welcome back to my YouTube channel. Oh, did we start? We started the video. Thank you. All right, and stop. Thank you. Okay, so section 6.8 and 6.9 are transforming functions and regression of these polynomial functions. I will tell you, we have learned everything that we need to learn to do these problems right now. The difficulty is not in new material. The difficulty comes in how we apply the material that we already know to polynomial functions. Now, this first slide is not new. You can write down whatever you want to write down. The key piece here, if you want to jog your memory, is that. But we've already learned that. Let's take a look at it, though. Let's refresh our memories. Vertical translation. Now, any type of translation is a plus or minus, right? And anything happening on the outside is a vertical something. So if I add or subtract on the outside, that's moving it up and down, shifting it up and down. If I add or subtract on the inside of f of x, f of, say, x plus 4, that'd be a left 4. That means that I'm going to plug in x plus 4 everywhere where I see x, and then simplify accordingly. That's a horizontal translation. That's a horizontal shift left or right of however many units. Vertical stretch and compression and horizontal stretch and compression, those are the multiplication ones. Vertical, again, anything happening on the outside, I'm going to multiply by that value, and it's just straight up, that's the value. Like if I want a vertical stretch by 3, I multiply the entire equation by 3. It's a vertical compression by 1/2, I multiply the entire equation by 1/2. Now, horizontal is different, and that goes for translations as well. Remember that they are the inverses of one another, right? They are inverses. If I want to translate 4 units to the left, I've got to go to the additive inverse of -4, positive 4. X plus 4 goes in the parentheses. If I want to horizontally stretch or compress, the multiplicative inverse, the reciprocal of that value, gets put into the into the parentheses, into the function. So say I wanted to horizontally stretch by 3. That'd be a 1/3 times x inside parentheses. Say I wanted to horizontally compress by a factor of 1/4, by a quarter. I'd be multiplying by 4x inside the parentheses. Remember, anything horizontal is the weird stuff. You've got to go the inverses, whether it's additive or multiplicative. Anything vertical is a little bit more straightforward, right? If I'm adding or subtracting, say if I'm adding 10 units to the end, well, that's just a vertical translation of 10 units. If I'm subtracting 7 units from the end, that's just a shift downward 7 units. And then we have the reflections. Negative on the outside reflects across the x-axis. Negative on the inside reflects across the y-axis. Okay. Those are all exact same. Everything of what I've said just right then was review. We've done this already, I think, 3 times now, maybe just 2 times. But we've done this a couple times already. Okay. These rules are the exact same thing that they were before. The difficulty lies in how do we apply it to polynomials. Like take, for example, this. Everybody focus up here on the whiteboard real quick. If I've got, I don't know, x to the 4th plus 7, right? Say I had a simple quartic binomial, right? Just 2 terms, x to the 4th plus 7. And say I wanted to shift it left 2 units. Left 2 units. That would be an x plus 2 inside parentheses, right? So I would remove x, and in its place, x plus 2 to the 4th power plus 7. Now here's the issue with polynomials. Here's where the difficulty lies. You'd have to simplify all of that out. Right? That's where this problem becomes difficult. You'd have to multiply all of these things together. You'd have to FOIL here, and then get the 2 trinomials and multiply those 2 trinomials together. So that's where the difficulty lies. The difficulty lies in the simplification, not, really how to transform. Okay? That's horizontal because it goes in for x, That's hard in and of itself, right? Well, what if I had done this? And now I said move it left 2 units. Well, now it becomes this. Oh, that's important. Woof. Holy cow. So now this becomes this. And I've run out of room. Right? Holy chicken nuggets, right? Now that's something, seems like something I would probably put on a group text, right? Yes, probably. Where, again, the difficulty is not in, maybe that's the evil version, right? That would be more like the evil version. The difficulty does not lie in what we do, but how we simplify it, okay? So that's what we're going to be looking at. All right. So our original function is an x to the third minus 6. Write the rule for each function and sketch its graph. Now, this in here, sketch its graph. I will never ask you to graph something by hand from a transformation, okay? If I'm going to ask you to graph by hand, it's what we did yesterday, okay? I'm not going to ask you, that's mean of me, to find a function, transform it, then graph again, all by hand. You will have your calculator if you want to ever check to see if the graph is doing what you think it should. Because I'm going to tell you how to transform these things. You can always go into your calculator and say, okay, did it do what I think it should have done, right? Did it actually move 2 left? Did it act, because when you're all the way done with this and fully simplified down, you should be able to plug it in and see initial function, new function, right? Just shift it 2 units to the left. If it doesn't, maybe you did something wrong and you got to go back and rework. Thank you. Lane Evans, what class did you skip? Lane.
Probably study hall.
Probably, like you did.
I put my name in, but apparently they don't count it.
Here. All right, so again, you will have your calculator. If I ever ask you to sketch something, don't throw your calculator on.
Can I take this now?
You want to go down there now?
I have a test next period, and I don't want to like miss the start.
Sure, just miss my class.
It's on the video.
Oh, okay, well, that's fine. Go ahead.
I'll watch the video.
Go ahead. We're just gonna talk bad about you when you leave.
I'll watch the video.
Explain the video.
I'll listen to the video. You're gonna talk bad about it.
So there's this Lane kid. So again, if I ever ask you to sketch the graph, all I'm asking you to do there is just put it in your calculator and sketch what it looks like and confirm that it's doing what you think it should. I'm doing that for you. So what is this? What type of transformation is this? Down 2. Down 2. Is it in the parentheses? No, it's outside, which means it's vertical. Vertical something. And it's pretty straightforward in vertical. You just go down 2. So what does that mean? So I simply just take my old function, here's g of x, my old function, and just go, oops, sorry. Here's my old function. There's f of x. Those two things are equivalent, and now I just do minus 2 to it. Yes, just as simple as that. So g of x is equal to x to the third minus 8. Wow, that's nice. So what I would ask you to do is to go in your calculator. You don't have to do this right now, but on your homework, you might want to do a couple of these where you graph the original, you graph the new, and confirm the fact that it does push it 2 units downward. Because you know, this one, there's not much simplification you do. You just take negative 6 minus 2, and you're there, and boom, there's really not a lot of error that could go wrong in that. But if you're doing something like what we wrote up on the whiteboard, yeah, you might want to check it just to make sure you got that right. Okay, what is this? Horizontal what? Not stretch, I'm not multiplying. Shift left 3 units. So this is a left 3. Left 3. And the original was an x to the third minus 6. f of x is x to the third minus 6. So what do we do with this? Well, it's in parentheses, right? So now what I'm going to do is I'm going to go in and remove x and in its place write x plus 3. So my h of x is going to be equal to, it was x to the third minus 6, now it's x plus 3 to the third minus 6. You're going to find whenever we do horizontal things, life is tough. Vertical things, life is a little bit more easy. But horizontal things, that makes life a little difficult. What does that mean by, what do I mean by that? Well, I've got to do this now. Hi, Lane.
Hello.
Welcome in.
They just didn't see my name on that.
Oh, really?
Yeah.
Oh.
It's crazy.
Don't talk bad about it. We recorded.
Oh, that wasn't bad.
So now I just multiply now. We get x plus 3, x squared plus 6x plus 9. Hey, have you guys ever learned that trick, the perfect square trinomial trick? I've been noticing that you guys don't know this. If you square a square a binomial like this, the rule is square the first, double the product, square the last. Square the first, double the product, square the last. What's x squared? What's the product of 3 and x? 3x, double it, 6x, square the last. 3 squared is 9. Whenever you square a binomial, it's square the first, double the product, square the last. That came to mind because I'm teaching that to my Algebra 1 students today. Square the first, double the product, square the last. Now here, just got to multiply it in. So we've got x to the third plus 6x squared plus 9x plus 3x squared plus 18x plus 27 minus 6. Don't forget about that minus 6. That just vanishes into thin air for a lot of you. Yeah, you have to pay attention to what was in the equation and carry it through. Don't get careless. X to the third plus 9x squared plus 27x plus 21. What was it? H of x? H of x. Ooh, fancy H. We all right?
All right.
We're good?
Yep. Good.
Questions about that? Okay. So again, something horizontal, a little bit more work that's involved. Anything vertical, straightforward. Horizontal, not so much. Oof. Oh my gosh, quit banging your head against the wall. Whoever that is.
Really? How is it me? I'm like 3 feet away from the wall. You can reach. 1.5. Alright. It's debatable. It's debatable.
All right. So I've got a new function. Now I'm not giving you the equation. I'm giving you in words what to do with it. I'm giving you in words what to do with it, and you're going to have to come up with, what does that mean in terms of the equation? So for example, I want to reflect this across the x-axis. What does that tell me to do? Where do I put the negative? Outside or inside? Outside. Reflecting it across the x-axis is negative f of x. So what does that mean? That means that g of x, my new function, is going to be the opposite of my entire function. Entirety of f of x gets this negative. This all changes. Okay, so now this turns into g of x is equal to negative x to the third minus 5x squared plus 8x minus 1. Everybody's sign changes. Even the constant that's sitting out there in the end, that sign changes as well. Just think about it. If I'm reflecting across the x-axis, and I've got a positive y-intercept, like plus 1, and I reflect that over the x-axis, isn't it go down to negative 1? Doesn't the y-intercept change? So you've got to reflect it accordingly. All right, now, let's try this. Let's now reflect this across the x-axis, or sorry, the y-axis. We did the x-axis, now we're going to do the y-axis. How is this different? Well, where does the negative go now? The inside. So that means, okay, now that means this is f of negative x, right? Okay, what was my original? Looks like g of x is going to be now negative x to the third plus 5 times negative x squared minus 8 times negative x plus 1. Does my constant change? Does my y-intercept change when I reflect across the y-axis? No. If it's on the y-axis and you reflect it, it does not move. What moves, well, or what changes, I guess I should say, is anything with an odd power. Because think about it this way. If I take negative x to the third power, that's like saying, okay, negative x to the third, right? Once I simplify it. Negative times a negative times a negative will stay negative. But what happens to the negative inside the x squared? Goes away, right? It doesn't have any effect. What happens to my negative here? It stays and turns that negative 8 to positive 8. And the 1 stays positive out there on the end. Even powers of x will not change. Odd powers of x will change. Even powers of x will change, or sorry, will not change. Odd powers of x will change. Yes, I'm considering 0 and even power, because that'd be like 1x to the 0 at the end. All right. Sound good? Yeah? Okay.
There should be an X. Yeah.
Oh, sorry.
Good job, Ryan.
Just testing to make sure you're all paying attention, you know. I feel like I did that first period too, like at that same moment. Like I forgot that X there too.
It's like deja vu.
It's like deja vu all over again. I hate when people say that. Deja vu all over again. That's so redundant. Deja vu means you're experiencing something again. So deja vu all over again means you're experiencing something again all over again.
Maybe they are.
So it's like for the fourth time or like whatever.
Yeah.
Again, let me remind you, there are directions on the homework tonight that says draw F and G on the same coordinate plane. You don't have to do that. I'm not going to ask you to graph tonight. If anything, you can just sketch what it looks like. But that's, again, totally up to you. The graphing calculator is there for you as a tool to make sure that the transformation happened the way that you think it should have happened. All right, so what is my transformation? What is this telling me to do? Bless you.
Thank you.
What is this telling me to do? Vertical compression, right? I'm multiplying so that we know it's a stretch or compression. It's on the outside, so it's vertical. And since it's vertical, it's a compression, because it's straightforward, by 1/2. I don't have to do anything to that number. If it was horizontal, if it was inside, I'd have to take the reciprocal of that value. But I don't. It's on the outside. Yes?
On the test, will you want us to write like in words what it is too, like vertical compression or?
Yes, and also make sure that you have by the factor of. Like, make sure you don't just say vertical compression. Say vertical compression by a factor of 1/2 or by 1/2.
Okay.
That make sense?
Yeah.
Okay, so let's actually perform this on that function up there. So g of x is going to be, okay, anything vertical is not so bad. I just basically take 1/2 of the entire f of x. 2x to the fourth minus 6x squared plus 1. Okay, so that's quite simple then. X to the fourth minus 3x squared plus 1/2. And that's it. Again, vertical things are good. Okay, let me get this one up there. Whoa. Come on. There we go. Okay, what is this telling me to do now? Horizontal stretch by 3. Horizontal stretch by 3. Horizontal stretch by 3. Okay, so now what do? I go back to my original equation and I say, okay, everywhere where I see an x, I'm going to replace it with 1/3 x. Now you've got to be careful when you do this, because watch, it's going to be a 2 times 1/3 x to the 4th minus 6 times 1/3 x squared plus 1. Does everybody see what I did there? What are those parentheses implying that I do with that 4th power? What do I have to do to with that 4th power? I have to distribute it. The 1/3 also gets raised to the 4th power. Okay, what is 1/3 to the 4th? 1/81. Good. 1/81. 2 times 1/81. How do we get that? Well, isn't 1/3 to the 4th power 1 to the 4th over 3 to the 4th? Right? We can distribute all the way into the bits of the fraction. 1 to the 4th, 3 to the 4th. 3 to the 4th is 81. That's where we get that. And now we do the same thing here. This is 6 times 1/3 squared is 1/9 x squared plus 1. And now we just simplify. 2/81 x to the 4th minus, 6/9, that's 2/3 plus 1. There's my h of x. And then you could think about it this way. If that's a really weird answer for some of you, right? Like you may be thinking, I got some really weird fractions. How do I know that that's right? Put it in your calculator. Plug it into your calculator. Plug in the original. Plug in this new one that you've got. And see if it actually horizontally stretches by a factor of 3. Is it pulling it outward? You'd find that it is indeed doing that. Last type of problem we'll do is where we chain them together. Again, this is just like what we do with quadratics and linears. You're just chaining them together now. Reminder, just go in order that they're presented to you. Like I'm gonna have f of x is 6x to the 3rd minus 3, and then I'm gonna take the reflection across the y-axis and then chain it with the shift 2 units down. I'm going to start by reflecting it across the y-axis, and then I'm going to shift it 2 units down. Shall we? We shall. Okay, so reflecting it across the y-axis. What's the rule? What do I have to do? Negative on the inside, right? Negative on the inside. F of negative x. F of negative x. Oops, negative x. So that gives me g of x, kind of halfway there, g of x, is 6 times negative x to the 3rd minus 3. Does that negative stay or go? Stays. So g of x, now we'll pull it all the way out in front, negative 6x to the 3rd minus 3. Don't change the constant term. The constant term didn't have an x with it, so don't put a negative with it. And now we shift it 2 units down. Sweet. A vertical thing. Let's shift it 2 units down. Just put negative minus 2 at the end. Just changes the y-intercept 2 units down. Negative 6x to the 3rd minus 5. Done. That make sense? Again, you want to say, please give me a million vertical things, because that, who is calling me?
Oh, wait.
How was my This is embarrassing on that video.
You want to pause it? Go on speaker.
No, that's okay. They'll leave a voicemail. It's really important. Somebody's calling from Alliance.
Oh, Alliance.
Compress vertically by a factor of 1/3 Then shift 2 units right. I believe we're going to use the same one, 6x to the third minus 3. 6x to the third minus 3. Okay, compress vertically by a factor of 1/3. What's the rule for compressing it vertically? 1/3 f of x, right? 1/3 f of x. So that's telling me that I need to take 1/3 of the entire function, 6x to the third minus 3. Right? I've got to take 1/3 of all of that. So I've got to distribute it. So I get halfway there, g of x is 2x cubed minus 1. And now I have to shift it to right. Okay, 2 to the right is what? Minus 2 inside, right? Minus 2 inside, x minus 2. So what is that telling me? That's telling me, well, I've got to do this. 2 times x minus 2 cubed minus 1. Guys, a huge mistake that happens all the time on the test, you guys leave it like this. Guys, if you leave it like this, you're cutting out like half the work of the problem. Like if this was like a 6-point problem, I'd have to take off like 3 or 4 points because you're not doing the hard stuff, right? The hard stuff comes in the simplification. So g of x is 2, x minus 2, x minus 2, x minus 2, minus 1, just like we did over there before. So again, so g of x is going to be 2, and then I'm going to multiply these two together. Square the first, double the product, square the last. And now we, you know what I'm going to do? I'm going to do this next. Look. I'm just going to do that. 2x minus 4. You see what I did there? I just already distributed into 2. So this 2x minus 4 will carry it in. 2x to the third minus 8x squared plus 8x minus 4x squared plus 16x minus 16. Don't forget about the minus 1 that was sitting out there in the end. Just double check my answer. 2x to the third minus 8x squared plus 8x negative 4x squared plus 16x minus 16. Okay, good. So therefore we have final g of x is 2x to the third minus 12x squared plus 24x minus 17.
That's what I got. But you haven't wrote anything down.
Yeah, not one.
Good.
No, it's not. There's still nothing.
All right, everybody, have a great day out there in YouTube land. Everybody say bye.
Bye.
When?